Okay, in the previous video, you just learned about the basic rules of integration and how can we integrate when we are having exponential function. Please make sure you try again the examples that are given to you. So now we are going to see how can we integrate when we are given 1 over x and 1 over x plus b. Trust me, it is easy. Okay, so if you try to look at here, tak nak fikir panjang, just proceed to this part in the box here and just having it by your own. So just some example, if you are having integral of, if you want to integrate 1 over x plus with b respected to x, you will be having ln x plus with b over with a. Ambil yang asal, tambahkan ln kat atas ni, and then over with a here. Plus with c, don't forget this one. And here, the easiest one, integrate 1 over x respected to x, you will be having ln x plus with c. Okay, itu sama je lebih kurang, which is okay, so let's just proceed. Okay, have some example again here. If you try to look at here, if you are given x plus with b power of n, you can have in this way x plus with b power of n plus 1 over with n plus 1 multiplied with a. As an example, if you try to look at here, we are having 4 over with 2 minus 3 over x, 3x power of 5 here. And if you try to simplify this one, you can have in this way, 4 you can put outside, so and then you will be having 2 minus 3x power of negative 5. So negative 5 kat sini adalah kita punya n kan. So negative 5 plus 1 will be negative 4, and here negative 4 multiply with a negative 3. Negative 3 we've got it from here, which is derive the 2 minus 3x here respected to x, you will have negative 3. So therefore, you already got the answer, so you will be having this one. Again, then next one, when you are having this one, yang ini you can ignore if you doesn't want to do this one. Okay, just proceed what you have in the previous one. So let's say you are having fx, and then you are having fx at the denominator. At numerator here, if you derive the fx, you will be getting the same result as you derive the denominator. As an example, you are having x squared plus 1 here at the denominator. Okay, I hope you can see the cursor. So if you derive the x squared plus 1, you will be having 2x, right? So this is the result. So that's why if you try to integrate this one, you will be having ln x squared plus 1. But this is just some additional information, so I don't want to discuss more about this part. So let's just proceed for the next one. Okay, this is more examples, which is how can you try by your own there. So if you try to look at here, we are having you are going to integrate 2 over x respected to x. You can put outside the 2 at the outside as a constant here. So you are going to integrate 1 over x actually here. So integrate 1 over x, so now you will be having ln x kan. So dapat dah jawapan kat situ. So I hope you are clear. I hope you are clear about this part. If you want me to try to have it this one, so if you try to look at here, integral, you can put outside here 1 over x respected to x. So integrate 1 over x kan, kita akan dapat ln x plus with c. Don't forget we're having constant here too. So there you are. This is for number 1. As for the 2, Roman pun cerita yang sama. So having the answers, and please try again by your own here. Okay, and let's proceed. Okay, so we are done 2.1. Okay, so topic 2, integration of trigonometric functions. This is just some a simple one here, having the same definition of integration, which is integration is antiderivative, as we already know in the previous subtopic. Okay, so find the integration for trigonometric function. If you derive sine x, okay, if you derive sine x, you will be having cos x. If you derive cos x, you will be having negative sine x. How do we know? You already learned in the previous semester. So nak you kena buka balik previous semester punya nota. So the antiderivative of cos x is sine x plus c, and so on. Okay, and then the next one, we are going to learn how can you integrate if you are having sine power of n or cos power of n. X here, which is n is an even integer. Double angle can be used to evaluate this function. Okay, so using double angle, as we know, cos 2ax, it will be 1 minus 2 sine squared ax, right? And how can we derive the sine squared ax? Sine squared ax, kita jadikan sine squared sine power of 2 ax here, make it as a subject. You'll be having 1 over 2 1 minus cos 2ax. Okay, kalau kita susun balik, kan dia beri dekat situ. We are given which is cos 2ax is equal to 1 minus 2 sin squared ax kan. Kan diberi. Mana kita dapat ni? Kita dapat ni daripada double angle punya formula. Macam mana tahu? Tengok balik kita punya double angle formula in the previous notes. Okay, the previous semester punya notes. Okay, so we are now our job is we want to integrate the sin squared ax. Okay, sin squared ax ni dapatnya daripada sini. So sekarang kita nak buat macam mana? Jadikan ini sebagai subject. So what can we have over here? You can have in this way. So which is we'll be having 1 minus with cos 2ax and over with to write everything here. So therefore you will be having this one lah. So how can we integrate this one? Actually equal to integral of 1 over 2 1 minus cos 2ax respected to x. So let's proceed. Okay, so you already have the notes here. Okay, which is your life here already easy for you lah. So if you want to integrate cos x, okay, you can refer in this one. If you want to integrate cos ax respected to x, it will be equal to sin ax over a plus with c. So let's say the a is equal to 1. So let's say the a is equal to 1. So kita katakan cos ax respected to x, you will be having sin ax. Sin ax plus over with a, right? Over with a plus with c, right? So let's say the a is equal to 1. So cos x, you want to integrate cos x, it will be equal to, we will be having the a is 1, so it will be having sin x plus with c. So you will be having this one. Having the same thing, if you derive the sin x, you will be having cos x, so it will be vice versa. This is just some additional notes that you can have. Okay, this is the first additional notes. If you want to add up by your own, and then if you want to derive sin x respect to x, sorry, if you want to integrate sin x respected to x, you will be having negative cos x plus with c. And if you want to integrate secant squared x respect to x, you will be having tangent x plus with c. So nanti boleh tambah sendiri. Okay, ini kalau tengok kat sini ada a untuk memudahkan lah. Let's say you are having a and so on here. Okay, hope you're clear about this one. And this part for this note, second column, not second, which is at the second row here, which is if you want to integrate sin squared at x respected to x or cos squared at x respected to x here. So you already give you the formula, so you just can use the formula directly here. Got it from here, okay? Saya dah tunjuk macam mana nak derive tadi. So let's proceed. Example 2.5, having a lot of questions here, and as you already have answers, please I want you to try it. Maybe you can try to stop the video and try to do all the questions here based on the integration formula. So and then you are going to check the answer later. Okay, let's check the answer. I already have the answers actually. So if you try to look at, you are going to integrate 1 2 over x cubed plus 3 sin 4x respected to x. So please try to refer on the formula. So you'll be having this one, negative 1 over x squared. Yang ini kalau tak fasih tu, sila fasihkan lagi. Please make sure you are going to integrate smoothly in this one. Okay, and then we'll be having yes, integrate sine here. Actually integrate sine, you'll be having cos, right? Okay, just some silly mistake here, which is you will be having minus with the 3 cos. Should be having cos actually here. Okay, should be cos here. So let's do this. Okay, cos here, cos 4x over 4, and you can simplify the answer by negative 1 over x squared minus 3 over 4 cos 4x plus with c. And the next one, the second one, you'll be having integrate e power of 2x. So please refer on how can we integrate the exponential function. So we'll be having e power of 2x over with 2, and we are going to integrate secant squared. Jangan tiba-tiba takut macam mana nak integrate ni, kita ada 2x plus pi. Please do remember 2x as a variable, pi as a constant. So you can have in this one, if you want to derive the 2x plus pi respected to x, so you can have a 2 here. And don't forget it is indefinite, so plus with C here. Okay. Okay, continue checking question number C. If you try to look at here, C given T1 plus cos cube x with cos square x respect to x. So what can you do over here? You can simplify it as this one. We are having 1 over cos squared x plus with cos x respect to x. Okay, so you'll be having this one. 1 over cos, as we know, we'll be having secant squared, right? So we'll just try to figure out on how can we integrate secant squared x plus with a cos x respect to x. This is not the final answer. You still need to do the works until you get the answer here, which is so for C is tangent x plus sine x plus c. As for question D, you can see from here you will be having sine 2x over with cos x respected to x. Okay, in this case, what can you do? Since we know we will be having sine 2x, sine 2x ni, you can open up using double angle, which is we will be having 2 sine x cos x over with cos x. You can simplify this one. So the result, you just need to integrate 2 sine x respected to x. In this case, you can have the answer as negative 2 cos x plus with c. As for the last question, I don't want to discuss this one since you already have the answers here. And if you try to look at the question for E, actually it is a simple question. It is a direct question. You just need to follow the formula that already given to you here in the previous page there. Okay, so we are done until subtopic 2. That's all for now. So we are gonna have this one. Let's proceed to the next video on the next subtopic.